All right, so there are two parts to this lesson. Today we're going to start talking about data. And data is like statistics and just kind of when we use numbers to make inferences about things or generally to see patterns. So the only thing that you've really done with data so far probably, you've done a little bit of this stuff before, but the only thing we've done so far this year has been scatter plots. So we're going to kind of extend that and do some more things with data just to get you ready for what you need to know. So this first part is 9.1. We're going to talk about measures of center and measures of spread. And these are just some terms, some math ways that we can measure and compare quantities of information. All right, so this first part is going to be mostly definitions. So make sure that you get good definitions down and how to calculate them because we're not really going to do a ton of examples. So the first thing that I would do is really label this part measures of center. That's because we're measuring where the center of data is, and there's two different ways to do that. We can do that using the mean. Remember, another word for mean is average. So the mean is when you sum the values and divide by the number of values in the set. So they kind of give an example down here at the bottom. I'll point to that. All right, here we go. So you've been given a number of text messages that you received in a given week on each day. So we're going to find the mean, you add all of them together and divide by 7 because there were 7 days or 7 numbers worth of data. And that's going to give you the mean or the average. The other note that you want to take is what the median is. So the median, some of you may remember this, like thinking about the median in the road, right? The median's that grassy part in between the two lanes. So the median is the middle set when the data is arranged in order. So we want to make sure that you get the data in order. So notice in this example down here at the bottom, they're finding the median. So the first thing they do is rewrite the data. They take this and they rewrite it in order. And then we're just finding the middle. So like crossing off top, bottom, top, bottom, top, bottom. And that's going to give you the middle data, whatever the middle point is. And so sometimes maybe one is a more accurate representation than another, and we'll kind of talk about when that is and why that is. So you need to know mean and median. And a lot of times you actually hear this with mode, and we're going to wait and talk about mode tomorrow when we start talking about histograms. So just know that that's coming, but right now all we care about is the mean and the median. All right, now this kind of second way to measure data is not necessarily just by the middle, but by how consistent the data is. So when we talk about consistency, we call that the measure of spread, and it's basically how compact is the data. So think about like test scores in a class, right? If everybody in the class is making, a 70 or an 80 on this test, or let's say everybody makes between a 70 and an 80 on a given test, that's pretty consistent because everybody's scoring in that same range. Versus if you have scores that range all the way from 30 to 100, that's a really big kind of range of data, and that means there's a lot of inconsistency in how people are scoring, so the data is going to be a little bit more tricky to make sense of. All right, so we're going to call this measures of spread, and there are actually 3 measures of spread. So we've got range and IQR, and we're going to talk about those, and there's one more that we're going to talk about here, and that'll be I think that will be the end of this video. All right, so the first one is range, and this is really easy. The only thing that people tend to get confused with range is they think about domain and range, and we're talking about a totally different thing here. So range is the difference between the greatest and the least value. So that example where I said 70 to 80, that has a range of 10, right? Because it's 80 minus 70 is 10 scores. The example that I said where scores range from 30 to 100, that has a range of 70, right? So that's one way to measure. And then we're going to break the data into what we call quartiles. So quartiles should make you think of quarters. And it's almost easier for me to explain what these other numbers are by looking at this example. So I'm going to go ahead and zoom in. And you probably just want to write down this example. So notice the first thing when we find measures of spread, and this needs to be in your note before you write this example down. When you do measures of spread, you have to put the data in order, and you're going to repeat values. So if multiple values repeat, just write them multiple times. Like notice here they've written 2 2s, 2 3s, 2 4s, right? So however many times that data gets repeated, if that means you have to write 17 8 times, then write it 8 times, right? You have to do that many times. So the range, I'm just going to point out to you, range is the maximum minus the minimum. It's this largest value minus the smallest value. So that's where I'm getting 8 from. Interquartile range kind of takes a minute for us to find. So notice we start, and I'm going to like label these so you can see what we're doing. We start by finding the median. So remember, you're kind of like checking off your boxes, top, bottom, and you're going to continue to do that until you find this middle number, which is called the median. So you're going to label that as the median. And then we want to go through and find what we call, so quartiles, we're breaking into like quarters, into fourths. We want to find the top and the bottom. So what we do is we take this data and we split it into this bottom half. And in the bottom half, we go through and we find the middle, top, bottom, top, bottom, top, bottom. And we find that the middle of the bottom half of the data is at 3. That's called the first quartile, and we label it Q1. Okay, so if you probably don't even want to write first quartile. If it were me, I would label this and I would write Q1. Okay, and then we're going to do the same thing on the top end. So the top end is going to say same thing, top, bottom, top, bottom, top, bottom. We're going to find this middle value, which is 7, and we're going to name it Q3. All right, that's going to be the third quartile. So the second quartile is that median there in the middle. Notice they call it Q2. Okay, what that does is that helps me see, and this is kind of tricky to make sense of. I may actually have to write over this. All right, that helps me see what we call the interquartile range, which is basically what's the range of the middle 50%. What's the range of the middle 50%? So I'm going to kind of explain that here in just a minute. But notice that we're doing, to find interquartile range, we're doing Q3 minus Q1. So this inner range is 4. And it just kind of tells you that, like maybe when you talk about that class of students that goes where the test scores go from 30 all the way to 100, well, maybe most of them are really still in that same, centralized point, but there's like a few people that just, or maybe even one person that did really bad on the low end or really good on the high end, that is kind of skewing the data. So what I want to talk to you about with this is how we make this look like a box plot and what the benefit of that is. Okay, so this is really, I called it a box plot. You're probably more familiar with hearing it called a box and whisker. So let me show you what this looks like, and let's just make sure that you get this example drawn really well in your notes. So box and whisker, you're going to start on a number line, and usually this number line is already given to you. So I'm going to start at 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm just plotting the numbers that they give me. So you're going to start in the middle, which is the Q2, which is at 5. All right, so I'm going to put a point at 5, and this is my median. This is the middle. And then I found, we're going to end up actually putting 5 points on here. I'm going to try to color code them for us. I found the interquartile range, Q3 is 7. I found that Q1 is 3, and I've got my minimum at 1 and my maximum at 9. And this one is very symmetrical. This is not generally what they look like, but the way these work is you get a box right here in the middle. This box is split into 2 sections, so you get kind of 2 ends to it, and then you have what they call these whiskers on the top end and the bottom end. And what this is supposed to highlight for you, because it's kind of a weird shape that you're drawing, right? What this is supposed to highlight for you is 25%, because you're breaking into quartiles, right? So we're looking at 25% of the data is in each of these sections. So 25%, 25%, 25%. And the reason we say that the interquartile range is important is because in the interquartile range, you're talking about the middle 50%. So if you want to say, well, where do the middle 50 lie, right? Like think about where do the majority of your data points lie? And I know it's not really majority because it's 50, but when we talk about the middle, that's kind of what we're going for. It's important to know where that middle 50 is kind of located. All right, so I think I'm going to try to show you one more quick example that's already done just so we can keep talking about and you get a good, clear picture of this. All right, so let me just show you this quick example. This isn't already done. You don't need to write anything down unless for some reason this example just makes more sense to you. All right, so You may actually write this down at the top, I don't know. It says you need 5 values to make the box plot. You need a minimum, quartile 1, the median, Q3, and the maximum. So know that those are the 5 points that you're looking for every time. All right, so in this example, again, you don't necessarily need to write anything down. They start by giving us 20 points of data. And we know that to find anything in the middle, we're going to have to order them from least to greatest. So that's what we've done here. My biggest tip, if you have to do that by hand, is to cross them off as you go. All right, then we're going to identify our 5 needed values. So in that, we need the minimum, the maximum, and they found this median here in the middle. So what I want to point to you out in this median, notice that since there were 20 values, this right here is like, I think, value 10 and 11. If you cross them off, you're going to end up with 2 in the middle. So to find the median, notice that they just found the average between those two to come up with the median. All right, then to find our Q3, what we've done is we've taken the top half. So this gets a little bit weird, okay? You haven't actually used this 8 because it's not actually the median. It just helped us find the median. So in my top half, I'm going to cross out until I get to what is the middle. My pen is lagging. All right, so notice that now I'm stuck in between these 2 points. And so the average between 10 and 10 is going to be 10. And we do the same kind of thing on this other side. Again, I'm using this 7 because I didn't actually use it when I found the median. So I'm going to find those data points, 4 on the top, 4 on the bottom. And now I'm between 4 and 4, which again, the average of 4 and 4 is 4. So I've gotten all these numbers. And then what we do is we draw this box plot. So I'm just going to show you what that looks like. And the biggest reason that I want to show this one to you is because these are not evenly distributed. And we're going to talk about that later. Even though this section looks larger than, like the second section looks larger than the first, for example, it is still 25% of the data. This section at the end is still 25% of the data. All right, so it's not, just because this section looks longer doesn't mean that it's more than 25%. All right, and then the last thing that we can just talk about here is that if we're going to do range, notice on this one, the range is going to be 12, because I do 14 minus 2, right? 14 minus 2. And then if I do interquartile range, which we call IQR, that's going to be 6, because I'm going to do 10 minus 4. So this interquartile range should always be smaller than the range because you're talking about, it's inner. It's part of that larger range set. All right.